To be proportional means to be related in similar ways. Like the example that we talked about. If we talked about the people in Africa, when I was in South Africa this summer, we went through a township, which is a very poor part, and the people that were there had specific amount of water that was rationed to them depending on the quantity of people they had in their household. So it was proportional. If they were to get 2 gallons of water per person, we would call this a unit rate. And so that means that 2 gallons is related to 1 person in the same way that how many gallons would be related to 5 people? 10. That is the proportionality. Proportions show relationships between quantities. What kind of visual thinking exercise have we used that shows analogies or relationships?
I forgot what it's called.
So if I was to show the relationship, in this case, what I could do is I could say, we could use our little bridge map. And the relating factor is the gallons of water. And we would say 2 gallons is related to 1 person as 10 gallons is related to 5 people. So this is the relationship between gallons of water and number of people. When things are proportional, we can figure out unknown quantities, as you will see in the future. So proportions show relationships between quantities. So if I was to ask you, how can you show a relationship between the following statement? Juan's height is related to Juan's arm span in the same way that Julia's height is related to Julia's arm span. And so how could I show this visually with a visible thinking? We would say Juan's height is related to his arm span as Julia's height is related to Julia's arm span. And the relating factor is height is related to arm span. Okay? Now, this is the visible thinking way of doing it. The proportional or mathematical way, and this is the part that is going to be really important for you guys to see, because as we move these proportions into equations, it's going to be critical that you understand how to set it up. If I was to set this up mathematically, visibly, as a mathematical visible thinking, I would write it like this. Well, let me ask you before I do that. How do I show a relationship between 8 cats to 2 dogs?
You put 8 to 2.
You write 8 to 2. You could either write 8 to 2 or
you do 8 and then 2 dogs.
8 to 2 or 8 over 2. Very good. So I can see that relationships between quantities can be shown by using a visible thinking routine, such as this, a bridge map, or by using the word to between the 2 quantities, or the colon between the 2 quantities, or the fraction bar. That fraction bar is also division, but it can also be thought of as a word is to. So if I was to write this statement as a mathematical visible thinking, I would write, how? How would I write that? Let's start with the idea of Juan's height. How do I write Juan's height is related to the arm span? So I could say Juan height is to Juan's arm as, that's the as right there, kind of like the thinking, right? As Julia's height is related to Julia's arm. So that little bridge map that we use is the same method. Juan's height is to Juan's arm. The equal to is the same thing as the word as. Julia's height is to Julia's arm. This is the mathematical way of writing it. Now, we can use this bridge map to set up proportions all the time. When things are proportional, as you guys said, they are related in similar ways. So when we have similarities, we have proportions. And the most important thing that you need to know from the word proportion or from proportions themselves is that proportions are called the equality of two ratios or rates. They're related to each other in the same way. And the words in the same way means equal to. That's where you came up, Bennett, with the idea of equal to, right? Because it's not necessarily exactly equal. Juan's arm is not exactly equal to Julia's arm because Juan's arm is Juan's arm. Julia's arm is Julia's arm. So they're not the same exact thing, but they're related to each other. And so proportions are equality statements. Equality statements. They are related in the same way. How would I read this proportion using, let's say, my analogy bridge map? How would you read this to me? What would you say?
A is equal to C.
Let's put it into a bridge map. A is related to B as C is related to D. And proportions have what we call equal cross products. What does the word product mean? To a, yes. Cross products are the answers to multiplication problems. And so therefore, if I say A is related to B as C is related to D, the cross products are the two numbers that are diagonal going to get multiplied. So it would be A times D is AD. That's the product of A times D. So if A is related to B as C is related to D, then that means they are proportional, which means their cross products are equal, which means that AD must equal BC. Always. That is what proportional means. Proportional means that their cross products are equal. Let me show you mathematically. If I said to you that 12/13 is equal to 24/26, you would go back into your probably early middle school or elementary days where you talked about equivalent fractions. Equivalent means equal in value. So 12/13 and 24/26 are equal in value. They just look differently. Because what you did to the 12, you also did to the 13. So they're equal. So we know that, yes, this statement here is true. 12/13 is equal to 24/26. But because a fraction is equal to a fraction, this is a proportion. 12 is to 13 as 24 is to 26. And if things are proportional, their cross products are equal. That means that 12 times 26, which is equal to 312, must be equal to 13 times 24, which also is 312s. So this is just showing you the fact that when two fractions are equal, it means they are proportional. And if things are proportional, it means their cross products are equal. So how can I use this in the real world? When we're trying to find unknown quantities that are proportional rates, we remember the fact that proportions have equal cross products. When you have two fractions that are equal to each other, it means they are in proportion. And if they are in proportion, it means that their cross products are equal. So if I said to you, hey, Lily wants to know how many cups of flour she needs to make cake for 30 people. If the recipe for 6 people calls for 5 cups of flour, how many cups does she need to bake for 30 people?
25.
So mathematically, we know that the amount of cups that she has for 6 people is 5 cups of flour. So we would say 6 people is related to 5 cups as she wants to know how many cups. How many cups is related to, how many cups is related to 30 people? There's my relation. There's my analogy. How do I set this up as a mathematical proportion? Mathematically, that would be looked at like this. So look at the black writing and now look at the red. 6 people is related to 5 cups as 30 people is related to how many cups, which is my unknown. And we know that when you have proportions, what do we know about their cross products? They're equal. So that means that if I am trying to solve for an unknown quantity, you are going to set up an equation. 6 times x is 6x. That's going to equal the same thing as 5 times 30, which is 150. And then when you do the math, how do I solve? Going back to equations, how do I solve for x? Divide by 6. X is going to equal, and then we're going to do our 150 divided by 6. 6 goes into 15 twice. With 3 left over, bring down the 0. 6 goes into 35. I know that Lily's going to need 5 cups of flour in order to make enough for 30 people. Okay, so here is the written amount. We set up a relationship between people and cups of flour. Is the first one proportional?
Yeah.
Yes, it is. Because if we are checking to see if things are proportional, we want to know if their cross products are equal. 8 times 12 is 96. We want to know, is this equal to 3 times 32, which also is 96? So the answer is yes.
Yes, indeed.
They are proportional. The next one, 4 times 27. Well, let's see. 27 times 4. 7 times 4 is 28. Carry the 2. 4 times 2 is 8 plus 2 is 10. That gives me 108. I want to know if it's equal to 3 times 36. 36 times 3. 6 times 3 is 18. Carry the 1. 3 times 3 is 9 plus 1 is 10. It is. So, yes. I changed this a little bit, specifically because I want you guys to get a no, so you can see what it looks like. I want to know if these two fractions are equivalent, 15/18ths and 10/11ths. So I'm going to cross multiply. 18 times 10 is 180. Is that equal to 11 times 15? Well, 11 times 15, if you remember the trick of 11 times, you take the 1 and the 5, and then you add 1 and 5 and you get 6. That's 165. The answer is no.
Wait, I thought it was a 12.
So no. These are just as simple in the sense that you already know that they are in proportion because the instructions tell you to solve for the unknown quantity in the proportion. So you already know that these are in proportion. Not to mention the fact that you see that equal sign in between those two ratios, which should be the next clue that the two fractions are in proportion. And if you know that things are in proportion, then you know that their cross products are equal, which means you actually physically create an equation. You're going to cross multiply, and like Zach mentioned, you're going to want to have the letter on the left, just because that's just the easiest way to solve. So when you cross multiply, you get 18 times m, which is 18m, is equal to 81 times 12. Yeah, you're going to have to multiply it out. Let's multiply it. 2 times 8 is 16. So then we add a 0. 1 times 1 is 1. 1 times 8 is 8. Add down and you get 972. Now, what is the next thing that I have to do? Yes, you divide by 18. So when you divide both sides by 18, you're going to have to do long division. Oh no, but that's all right. We could do this. You're going to go 972 divided by 18. And 18 goes into 97. Well, let's see. 10 times 9 is 90. So let's try 5. 8 times 5 is 40. Carry the 4. 5 and 4 is 90. That's perfect. That's 90. Subtract. You get 7. Bring down the 2. How many times does 18 go into 72?
4 times.
Well, let's see. 18 times 2 is 36.
No, 4.
And 36 and 36 is 72. So 4. 4 times 8 is 32. Carry the 3. 4 plus 3 is 72. That's 0 left over.
No, but 18 times 4 is,
So, yep, 16 times u is equal to 4 times 30, which is 120. Then I divide by 16. I think Jake's right, yep. And then we're going to do the, long division. 120 divided by 16. Let's see, 16 times 5. 5 times 6 is 30. Carry the 3. 5 and 3 is 8. Let's say 7. 6 times 7 is 42. Carry the 4. 7 and 4 is 112. Yep. So 7. That's 112 with 8 left over. Uh-oh, I have to add a decimal point.
7.
Bring down the 0.
7. I knew that.
Goes into 85 times because I remember this one here. So that's 80 evenly. So the answer, U, is equal to 7.5. When we go to solve this proportion, it's the same method as with regular numbers without fractions or decimals. We're going to multiply 2.7 times x, which is 2.7x. That's equal to 3.0 times 3.6. Now, as a quick refresher, remember that when you're multiplying, you don't need to line up the decimal places. That's only for adding. It just so happens that they line up because they're the same quantity of place values. Then you just multiply like normal. 6 times 0 is 6. 6 times 3 is 18. Add a 0. And then we go to the 3. 3 times 0 is 0. 3 times 3 is 9. Add. Now, at this point, you've got to count how many decimal places are in the original problem. 1, 2. 1, 2 have to be in the answer, so 10.8. Now, you've got to divide by 2.7. I'm going to show you guys a trick. I used to always get confused as to where I move my decimal when I'm dividing. If you multiply a fraction if you multiply the numerator and the denominator by the same quantity, you're allowed to do that. You're leaving it equivalent. So if you have a fraction with decimals, you are absolutely allowed to move the decimal 1, and as long as you move the decimal 1 to the other one, and now you have 108 divided by 27, which is your regular division problem. So now I'm going to try out to see what's 20. I know 27 times 2 is 54, just because I memorized it, and that means times 4 is 108. So the answer is that x is equal to 4. So the other types of questions that you are going to have on Math Space are going to be questions such as these. It says, a jet ski travels 2.8 kilometers in 14 minutes at a constant speed. So that means it's proportional, it's consistent. How far does it travel in 2.6 hours? So if I was going to make a relationship, a bridge map, an analogy, I would say that the 2.8 kilometers is related to the 14 minutes because that's the rate. I'm going 2.8 kilometers in 14 minutes. That's related to this as how far, that's my distance. I don't know. That's my unknown. Let's say D for distance. In 2.6 hours. What do you notice about the rates that we're comparing?
That they are different.
They're different because one of them's talking about minutes and the other one's talking about hours. So, but it's exactly, it's about time. So you need to change it so that it's the same unit. Which is easier to change, minutes into hours or hours into minutes?
Minutes and hours.
Minutes into hours, I would divide by 60. Hours into minutes, I would multiply by 60. So how many minutes is 2.6 hours? Well, let's see. 2 hours is 120 minutes. 0.6 hours is 6/10 of an hour. At this point, you might be a little confused doing it the long way, so you might just well go 2.6 hours multiplied by 60 minutes.
Is there going to be a question?
And then you're going to multiply it out. 6 times 6 is 36. 12 and 3 is 15. 1560 with one decimal, 156 minutes. So this is really 156 minutes. And now it's apples to apples, oranges to oranges, kilometers to kilometers, minutes to minutes. We have 2.8 kilometers is related to the 14 minutes in the same way that how many kilometers is to the 156 minutes. And what do I do now? How can I solve this now?
Cross multiplication.
Cross multiply. 14 times D is equal to whatever 156 times 2.8 is. And again, you don't need to line up decimal places with multiplication. You just line up the units. 6 times 8 is 48, carry the 4. 40 and 4 is 44, carry the 4. 8 and 4 is 12, add a 0. 2 times 6 is 12, carry the 1. 2 and 5 is 10, and 1 is 11, carry another 1. 2, 1 is 2 plus 1 is 3. Add down, 8, 6, 3, 4. I need one decimal place, so I'm going to have one decimal place. 14 days is 436.8 minutes.
That's your answer?
Well, what is it asking me for?
You need to divide.
Yeah, I needed to divide now. So now you're going to divide. Now I want to make sure that you guys understand you're not going to have crazy decimals like this on the summative, but you are expected to be able to do this. So you're going to do 436.8 divided by 14. And 14 times 3 is 42. 1 left over, bring down to 16. 14 goes into 16 once. With 2 left over, bring down the 8 and into 28 twice. with 0 left over. So the answer is 31.2 kilometers. So, just so you guys understand, you're not going to have this much of the crazy stuff where you have to first change minutes, the hours into minutes. But at this point in your lives, you should be comfortable understanding that 156 minutes, the 2.6 hours is not the same as minutes. So to change it to minutes, you multiply it by 60. Okay, your homework is the math space, 4.2.